Hello and welcome to the Aligned Projects webinar series on engineering agile big data systems. In this webinar series, we are showing how the latest breakthroughs in computer science research are helping organizations to deal with the practical challenges of big data. The series consists of 5 case studies from a range of different sectors. In each case, we show how tools developed in the European Horizon 2020 Aligned project are enabling large communities of users to leverage the value of their data. In this, the first volume in the series, we'll be looking at collecting and curating high-quality datasets with the Dacura platform developed in Trinity College Dublin, and how this technology has been applied in the Seshat project, one of the world's most ambitious attempts to collect high-quality historical datasets. We'll start off by providing some background on the technology, what it does and what problem it is supposed to solve. Modern organizations have access to lots and lots of data. This data contains hidden value, patterns that can be detected by automated analysis to provide insights which can help to refine and improve business processes. The big problem is that real-world data is complex and messy. Although organizations have access to huge amounts of data, it's currently a vast amount of effort to get the right data and get it into good enough shape so that it can be analyzed by computers. Big data analytics has to date only really been successful in domains where there are simple regular log files that can be easily mapped to simple big questions. That's where we come in. Our technology is designed to automate the generation of high-quality machine-readable datasets. We use a rich semantic model of the desired dataset to generate much of the software that is needed to build and curate that dataset over time and to import existing data. The goal is to radically cut the time and resources required to extract value from existing information resources and curate that value over time, so that people can concentrate on the big questions and not the messy details of the data. Now we'll look at how we've used this technology to help the Seshat project solve their problem.
Seshat is a large-scale historical database.
Its purpose is to be able to see the macro patterns that characterize historical processes.
The Seshat researchers began by defining a sample of 30 locations from all over the world. For each location, they recorded all the societies that had controlled that area throughout history and answered over 1,000 questions about each society, describing its population, technology, religion, infrastructure, and so on. A wiki was used to collect the data. A special codebook page defined the full list of questions. Researchers added data to the system by creating a copy of the codebook page for each society and filling in answers to all the questions using a special syntax that encoded uncertainty, disagreement, and temporal scope, all very important in this domain. Extensive comments and citations were included along with the raw data. This system worked well for amassing data. Over 150,000 facts covering hundreds of historical societies were quickly compiled. However, as the dataset grew and the focus moved from collection to analysis, several significant problems emerged. The fundamental problem is that a wiki is designed for human presentation and editing of data. From a machine's point of view, it is semi-structured. It lacks any type information, and the meaning of the elements depends on their context within a jumble of HTML. Researchers also had a hard time getting the special syntax right, but these structured fragments were the easiest part for the machines. In 2015, we introduced a syntax validation and scraping tool, which helped the Seshat team to remove basic syntax errors from the data. However, this wasn't enough to let the computers understand the data. All we could do was to dump the values into a spreadsheet along with some contextual information to help humans interpret it, and many type errors, copying errors and typos remained. The limitations of the wiki software also impacted agility. The Seshat codebook was in a state of rapid evolution, but each change needed to be manually copied to all existing data pages, a costly and error-prone task. There was also no easy way to express spatial data through the wiki, so this data came to be stored in individual researchers' GIS systems. It also offered no support for preparing the data for publication. Productivity suffered, as an increasing proportion of resources had to be devoted to data curation and cleaning. Some of the corrections weren't copied back to the wiki, and spreadsheets became the authoritative source for some sections of the data. Finally, rather than duplicating effort, the Seshat researchers wanted to reuse data from existing datasets such as Wikipedia and the Pleiades Historical Gazette. So let's see how our technology helps Seshat solve their problems. The first step is to use Dacura's modeling tool to define the data classes that we need. Entity classes are special. They are the basic units of data curation, the business objects that we are interested in. Properties define the shapes that the data can take. They relate classes to other classes or to basic data types such as integers and strings. Restrictions can apply cardinality and other constraints to properties. Properties can also be enumerated types, where the value must be chosen from a predefined list of choices. The tool allows users to import models from a range of sources, including HTML. We can run it from within the browser to import all the questions defined in the Seshat codebook to properties in our model. And once we've created the model, Dacura generates a data curation machine. This includes user interfaces, which can be used to create data objects. The interfaces are enriched with microprograms which know how to represent each property. All updates to data pass through a data quality analytics service, which rejects any data that fails to meet the model's constraints, ensuring that the data set remains correct over time. Dacura also generates data harvesting tools. Let's see how we can use them to import the data from the Seshat wiki into our system. When Dacura imports properties, it associates them with the HTML context where they were imported from. It uses the data validation service to test the value of each property in order to identify errors. It can even automatically correct several types of common error. It injects microprograms into the HTML which show exactly how the source data has been mapped to model elements, complete with user interfaces, citations, comments, and other annotations. The tool allows users to view and modify the import mappings. Once the user is happy with the mapping, they simply click a button and the entire wiki is imported. Now, Gavin will demonstrate how we extracted records of historical cities, wars, and battles from Wikipedia and integrated them with the Seshat data. We used the open source Unified Views tool and DBpedia, a structured RDF version of Wikipedia, both of which have been developed by our partners in Aligned, the Semantic Web Company and the University of Leipzig, respectively.
DBpedia stores a large quantity of useful information that can be mined for a wide range of applications. In the Seshat use case, we have utilized DBpedia as a source for a number of different objects in our system. 3 objects about which we can obtain additional information from DBpedia are wars, battles, and cities. In order to obtain this information, we can use a Sparkle endpoint, a sort of gateway which gives direct access to the DBpedia database. Using the Sparkle language, we can construct an object which is directly suitable for the Seshat database and can be loaded as instance data using Dacura's RDF loading capabilities. First, we construct a query. This involves constructing a Seshat object. In this case, we want to construct a battle which has a name, casualties, combatants, a date, the war that the battle is a constituent element of, its location, and a comment describing the battle. The object is constructed from the various properties which exist in DBpedia. We can choose a result format. For importation to Dacura, we might choose Turtle, which will give us data which can be directly loaded using Dacura's import capabilities. For humans, HTML gives a more readable presentation. As we see here, a number of historical battles are obtained, including the Battle of Actium. We can similarly obtain information on wars from DBpedia. In inspecting the data, we see that the date formats are not completely correct, and the information about casualties is unstructured. Dacura will load these as candidates and report the fact that these data points need to be cleaned, allowing humans or robots to attempt a cleanup of the candidate object for insertion into the type-correct data store. If we are clever, we can also obtain cities from the DBpedia database. Since most cities were created in the 20th century, we restrict our query to those cities which are either marked as destroyed or ancient. Using DBpedia, we can enrich the information in Dacura, and using Unified Views, we can automate much of this process. Unified Views gives us a framework for pipelining Sparkle queries such as the ones for battles, wars, and cities to construct merged RDF files for import to Dacura.
From this imported data, Dacura produces an enhanced correct by construction dataset++. Now we have the data where we want it. Every fragment is typed, precisely structured, and guaranteed to conform to whatever rules we have imposed. Because all our data is defined in RDF and AL, we have a very rich and expressive ontological representation. It's just straightforward to automatically convert it into the much simpler, feature-based formats required by data analytics programs. However, that's not all. Dacura's linked data platform provides us with a wide range of lifecycle management tools. Each candidate data object is versioned, and workflow rules can be defined to automate processing of updates. For example, we can require that all updates must be approved by somebody with a special role, an expert or manager, or processed by natural language processing tools to check for typos before they will be published. We also gain tremendous agility. For example, the system can analyze the effect of schema updates and automate the migration of existing data where possible, and schedule the rest for manual migration. Finally, we're going to look at how we can retrieve data from Dacura and do useful things with it. In April 2017, the Seshat researchers wanted to publish a subset of their dataset to accompany the first major research article that they had produced. We used Dacura's JavaScript client to fetch the necessary data from Dacura's API and presented an attractive HTML template for the public to browse. Because the data is enriched with microprograms which know how to display each property, the task of generating a website becomes trivial. All we have to do is to produce a HTML template and call a JavaScript mapping function, and the system generates a rich interactive website to display the data, complete with maps, annotations, citations, comments, and user feedback forms. But don't believe us. The published Seshat dataset is available for browsing on the web. In this presentation, we have showed how Dacura automated the production of a high-quality, correct-by-construction dataset from semi-structured resources and generated a wide range of tools to curate the dataset over time. This radically reduced the effort required to prepare and analyze the Seshat data, from years to hours, allowing the Seshat researchers to focus on big research questions rather than the messy details of the data. Thank you for your attention. If you have any queries about Dacura or Seshat, please don't hesitate to get in touch. This webinar is part of the Align series on engineering agile big data systems. There are 4 other webinars in the series which look at applying the latest breakthroughs in computer science research to the practical challenges of big data in different domains. You can find them, along with lots more videos, on the Aligned YouTube channel.